Okay, we're going to talk more about rational equations in this particular one. And the reason why is because rational equations have a lot of stuff that seems to go into it. And it makes it harder to remember everything. And there's aspects and principles you come from fractions only that you have to think about. You have to think about where variables are. And you have to look at the whole thing and make some decisions as to how you want to work your problem. Now, there are many different ways to go about working the problem. And I'm trying to simplify them into some ways that will make it easy for you to ask yourself, is it this, is it this, is it this? What do I do with those kind of things? So the first thing is we look at rational equations. Number one, is there a variable in the denominator? In other words, do I have something like 2 over x? That's a variable in the denominator. If there is, then you have restricted values, and another name for that is domain. And I tell you the word domain because they're going to use that in your homework. So therefore, if there is, like in this case, we have to designate the restricted values. And you do that by putting the variable expression equal to 0. So in this case, it would be x equals 0. So if 0 is in the denominator, 2 over 0 is undefined. And because 2 over 0 is undefined, x cannot equal 0. And this would be your domain expression. X cannot equal 0. 3. What is the structure of the equation? In other words, what do I mean by that? Structure A. One rational term equal to one rational term. Here would be an example. 3 over x minus 2 equal to 5 over x plus 3. Okay? One rational term equal to one rational term. What if my structure is this? One term, rational term, or one term equal to 2 or more terms. Okay? Here would be an example of that. 6 is equal to x over 5 plus 3. This is one term equal to 2 or more terms. Okay? C. What kind of terms are they? In other words, are they rational? Or are they fraction without variable? variables or are they integers? In other words, a rational would be something like 3 over x. A fraction without a variable would be 2/3. And an integer would be like the number 6. So in this here, we have an integer and a rational term with a variable. Okay? So these are the three kinds of things you're going to deal with. Or we might have two terms equaling two terms. So that would be another possibility. And so we're going to use the structure to our advantage. Okay, so let's look at what that is. I'm going to have to erase this. Okay. Use the structure to your advantage. Okay. So if I have that type A, remember with that type A, I had something like 6 over x plus 2 is equal to, how about 4 over, I don't know, x minus 1. If we have something like that with a type A, you will use cross products and then solve. So what will happen on this one? You would have this times this and this times this. So I'd have 6 times x minus 1, and notice it has to be in parentheses because the whole denominator has to multiply that numerator that's its cross product. So this would be 6x minus 6 is equal to 4x plus 8. We're going to subtract our variable term first. Remember, this is equation solving from earlier in our lesson, so we'd have 2x minus 6 is equal to 8. Add my 6 to the other side, and I have 2x is equal to 14. Divide by my 2, and I have x is equal to 7. Now, my restricted values, which I didn't do, you would have x plus 2 is equal to 0. Subtract that 2. And I have x is equal to negative 2. And x minus 1 is equal to 0. Add the 1. And I have x is equal to 1. So therefore, x cannot equal a negative 2 or a 1. Those are my restricted values. My answer came out 7, so my answer is a valid answer. So this is type A, where you've got one rational expression equal to another rational expression, and I can do cross products with that. Okay, type B. How do we want to tackle type B? If possible, move terms to have the same type on each side. Okay? So that would be the first step we would do. Now I don't remember what I put up here, but I think it was something like this. 6 is equal to 3 over x minus 2. Okay? So I want the same type on the same side. This is a different type than these are. So I'm going to add 2 to both sides and end up with 8 is equal to 3 over x. And I'm going to put 8 over 1 so I can do my cross products, and I have 8x is equal to 3 divided by 8. So x is equal to 3/8. And x cannot equal 0. That would be your domain. Okay? So, you notice how I put the same type on the same side. And that simplifies it really quickly that way. Okay, there's others that could happen on this. How about something like this? Okay, you will notice on this one, we have a variable fraction, we have a regular fraction, and we have a regular fraction. So my first thing is I want to get the regular fractions on the same side. So I'm going to subtract my 1/2 from both sides. And this is going to leave me with x over 4 is equal to, now, notice my denominators aren't the same. So to simplify this, I'm going to have to find that common denominator. Well, 2 goes into 6, so therefore 6 will be my common denominator. And since 6 is here, this one doesn't change at all. But this one over here, I'll have to multiply 2 times 3 to make 6. So therefore I have to multiply 3 times 1, because I have to do the same to the numerator and the denominator, giving me 5/6 minus 3/6, which is going to leave me with 2/6. Now I can do my cross products, and I will have 6x is equal to 8 divided by my 6. And I have x is equal to, simplify this, divided by 2, top and bottom. And I'm going to end up with 4/3. And just leave your fractions. That's usually a really good place to leave it. So you notice that I brought it so my same kind of fraction was on the same side, and then I made my common denominator so I could get what was left, and I had 2/6. That could have been simplified to 1/3 as well. And then I have my cross products. 6 times x is my 6x. 4 times 2 is 8, and then dividing by 6 on both sides, giving me 8/6, and simplify your fraction to 4/3. Okay? So that's what I mean by getting the same kinds of things together. All right? So those are the 2 type B. Now, type C was our last one. What kind of terms are they? Well, that's what we've used. We figured out what the terms were to do your 2 different types. Okay, so now let's just look at some examples of these 2 types. And we'll do several problems to help you. Use this system to help yourself. Okay, so let's look at this. X over 5 is equal to x over 6 minus 1. Okay, notice on this one, I have x's but they're in the numerator, so that's okay. I have a 5 here, an x over 5, and an x over 6 minus 1. This is an integer term. These are both rational terms. And yes, the variable is there, but it's in the numerator. So I'm going to get my 2 rational terms together by subtracting my x over 6 from both sides. That's going to give me 0 here. So this is going to equal my -1 over here. Over here I have an x over 5 minus an x over 6. So let's look at that. X over 5 minus x over 6. I'm going to need a common denominator to deal with that. and they have no factors in common, so my common denominator will simply be 30. Okay, so 5 times 6 is 30, so therefore I have to multiply my x times 6 and get 6x. 6 times 5 is 30, do the same to the top. So this is 5 times x, which is 5x. 6x minus 5x is going to leave me with 1x, or x, over 30. And it's going to equal negative 1 over 1, because I have to turn my integer term into a fraction. Now, cross products, I have x is equal to negative 1 times 30 is negative 30, and it's finished. You see how nice that is when you put those similar type terms together. Now let's look at this one. 7x over 4 is equal to x over 32 minus x over 8. Now notice on this one, I have a lot of things that are the same. I can either get the same denominator with everything, or I could just get the same denominator over here. It doesn't really matter which way you do it, okay? So, if we did that, let's see, which way would you like to do it? Would you like to do all of them the same or not? Let's just do this side over here. So 7x over 4 isn't going to change, but this one will. 8 goes into 32, so my x over 32 will not change, but this one, to become a 32, is going to require a multiplication by 4, making 4x. So I have 7x over 4 is equal to x minus 4x is a negative 3x over 32. Okay, so 4 times negative 3x is a negative 12x, and that's equal to 7x times 32 is 1422, 224x. Okay? So what's going to happen here? Well, I can go ahead and get it all on one side, and so if I add 12x over here, I'm going to end up with 0 is equal to 236x. Divide by 236. 0 divided by 236 is 0, so 0 is equal to x. So another type of example that we have on this. So let's look at some more examples. Okay, let's do this one over here. 4 minus 20 over x is equal to 9 minus 4. Okay? Well, I've got a integer terms here that we can immediately simplify to 5. And so I have 4 minus 20 over x. Integer, rational integer. X is in the denominator, therefore x cannot equal 0, because 0 would make it undefined. So my first step is I want my integers on the same side. So I'm going to subtract 4 from each side, and I'm going to have a negative 20 over x is equal to 1. So I'm going to write 1 over 1 as a rational expression. And now cross products, I get x is equal to a negative 20. You see the advantage of having the same type of term on the same side. It makes it easier. Okay. look at some more examples as soon as I get the board erased. Okay, 7 over x plus 1/5 equals 5 over x. Notice we do have an x in the denominator, so therefore my restricted value is x cannot equal 0. Now, I've got a rational expression with x in the denominator. Here I have a regular fraction with no variable, and on the other side I have a rational expression with x in the denominator. I notice right away that these have the same denominator, and they both have a variable in the denominator. So therefore, I am going to subtract this from this side and do the same over here. So I end up with the same kind of terms on one side. So I have 1/5 is left here is equal to 5 minus 7 is a negative 2 over x. Again, your cross products, 1 times x is x, and it's equal to 5 times negative 2 is a negative 10. I think we got one more of that kind, and we'll do it. 2 over 5x plus 1/4 is equal to 74 over 10x minus 1/3. This is the most complex one in the homework assignment. Notice these two both have x in the denominator. These two are simple fractions. So I want my simple fractions on one side, my variables in the denominator on the other side. So I think I am going to subtract my 74 over 10x and have the same thing here. And so that becomes 0. Then I'm going to subtract my 1/4 from both sides and do the same over here. So this is going to be rewritten now as 2 over 5x minus 74 over 10x is equal to negative 1/3 minus 1/4. Okay? Common denominator here. Well, 5 times 2 gives you 10, and so that would give me my 10x as my common denominator. This one has no change, so it comes just as it is. Multiply this by 2 and multiply this by 2, making this as a 4 over 10x. And then that's equal to 12 will be my common denominator here. Now, this is times 4, so times 4, negative 1 times 4 will be that negative 4. And times 3 times 3, so this will be 3. So 4 minus 74 will be a negative 70 over 10x. And that's equal to negative 4 minus 3 is a negative 7 over 12. Again, your cross products, negative 70x is equal to negative 70 times 12 will be negative 840. I believe I did that right. Okay. Divide by 70, negative 70 on both sides. And that's going to give me x is equal to negative 7 goes in negative 84 goes 12 times. So x equals 12. And that's a lot more complex than anything else that you would have done. So we're going to stop with that video and then do another one. It's been long enough.